And so that tab that you have going will probably start making some noise because we are live. So people can hear us. Let's see. Let's get a mic check from you.
Okay, testing 1, 2, 3.
That sounds
How
good.
do I sound? Pretty good?
That's good. I'll probably turn you up a little bit.
All right.
There it is. The L Megas has got oh, we are totally live. They see me right now. Didn't even do the intro. Hold on, people. There's the intro. Enjoy a little bit of the intro. But I messed up on that. Welcome, everybody. I'm MC Toon. This is the Toon Show. And tonight, we've got, I've got it's just myself. FCFE is still feeling a little under the weather. And so it is myself and, oh, that is a little bit, I'm cropping his hat. I'll fix that. Myself and Dr. Danny Faulkner. Welcome to the show, Danny.
Thank you, Mike. It's good to be here.
It's great to have you. So now, people, you may not know Danny. He is an astronomer, and it's in the, so this is all in the description. An astronomer, you taught at what university?
The University of South Carolina, Lancaster.
Okay, for quite a few years, and
Yeah.
and your PhD is in astronomy from where?
Indiana University.
Okay, Indiana. Excellent. And Danny has been involved in the flat Earth debunking community longer than I have. And right here is the book that Danny wrote, and Falling Flat. I obviously have a copy of it, and a very special copy. I'm really honored to have the signed copy of that. You said this is probably a year ago.
Mm-hmm.
April 15, 2021. So thank you for sending that. I appreciate it very much. It's a very good book. Lots of solid science in it. So there's that. Then you, after university, after teaching, you retired from that and went on to work for Answers in Genesis, correct?
Yeah, I've been here 9 years.
9 years at Answers in Genesis, which is a Christian organization.
Mm-hmm.
And you're the astronomer on staff, is that right? Is that
Yes.
how it is? So
A lot of people are surprised to find we have a research staff. My boss is a geologist. We also have a PhD biologist and a paleontologist as well. So we have 4 scientists on the research staff. We have one other scientist on our staff, but she's in administration.
okay, that's cool. And so there's some there seems to be a lot of contention that people have between organizations like that and science, and you clearly don't see a problem in that, and neither do I. So that's pretty cool. So anything else you'd like to add before we get into what we're talking about today?
No, it pretty well covers it.
All right. So the topic is, and this is very exciting, is the things that flat earthers get wrong about astronomy. And you have a presentation and some things that you want to go through. So as you go through it, if people have questions, send them to me. You can email me or send me a DM or just tag them in the chat here. So there you go. Anything? Go ahead at your leisure.
Okay. Well, I started this list probably about a year ago. I just one day sat down and I realized that I kept seeing the same false information being given again and again and again by flat earthers. So I said, well, I needed to make a list. I started with no particular order, just started writing them down as they occurred to me. I think my list now has 19 points on it. I also added a list dealing with physics things they get wrong. So I'm not giving that nearly as much thought, but that would make a good show at some time too, perhaps. So I'll get started on this. I'm not going to do them all tonight. I've got about 10 prepped. The first one I'm going to talk about is the claim that the moon is transparent. I've seen this claim many times. I haven't seen it in a while, but there used to be videos out there of the moon taken with stars shining through the moon. And as soon as I saw that, I realized those aren't stars. I'm not sure what they are. They could be noise. They could be hot pixels. I don't know, but they are not stars. And I want to share a couple of photos to explain what I'm talking about. So let me get to that right here. And I suddenly lost what I was going to do here. What happened to it? Oh, here it is. Is that it? What do you see? Nothing yet.
Oh, here it comes. There it is.
Not what not what I'm supposed to
I
show
see
you.
the YouTube window. Yeah, click to the other tab there. Well, you can go back to the share and then just hit the other tab. And I'll hit this tab in the meantime.
Okay, we went over this, and
I think you had the right window.
I did.
But then just
No, that's
then
the
hit
wrong
the
one.
tab 2 over. Keep that.
Ah, there you go.
There you
Okay.
go. That works.
All right. What I want to show is this photograph. Why is there a delay?
The delay, you pause the video on the other tab there. That's gonna affect you. So 2 tabs to the left.
2 tabs to the left.
There you go, and then hit pause. Yeah, click that quick, and then hit pause, and then go back to the tab you were just on. I think it's still going. You could even just close that window, or that tab, not the window, not that one, that one. Yep, just close that. There you go.
Is that good?
There
that good?
You go. Yep.
All right. I took this photograph a few years ago. It was during a occultation of Aldebaran. An occultation is when an object passes in front of another object. In this case, it's the moon, so it's called a lunar occultation. And you can see the half-lit moon there. We call it a first quarter. It's a little fuzzy for a couple of reasons. One of them is it's overexposed. You can tell that easily enough. Now, I don't know if you can see the little arrow I'm pointing here, but there's a little dot up here. Can you see that above the moon?
I do see that. It's like a bit of a line even, right?
Yeah, that's because it's a little I had a camera on a tripod and I had it zoomed, so a little shaky. That's Aldebaran. That's the brightest star that the moon can occult. It's not real bright. And the reason why it's not really bright is because the exposure is too short. And the reason why the moon is overexposed is because the exposure is too long. My point is, you have an extremely difficult time getting the moon with a proper exposure and a star at the same time, because the moon is so much brighter than even the brightest stars. Now, Aldebaran, again, is the brightest star that even gets this close to the moon, let alone gets occulted. And you really can't see. If I would have exposed the moon properly on this, Aldebaran would not show up at all. And that's the first photograph I took. And now about 20 minutes later, half hour later, I took this photograph, and you can't see Aldebaran anymore, can you?
No.
That's because the moon has passed in front of it. It's located about right there. And if the moon were transparent so that stars could be shining through it, then you would have no trouble seeing Aldebaran at all. Now, that was taken with a zoom lens on a camera on a tripod. Now, I got a nice Astro camera for Christmas a couple of months ago, and I've been experimenting with it. Recently, it was last month, I took this photograph of the waning gibbous moon. I think it's a pretty good photograph. You can see that it's pretty good exposure. It's not too long, not too short. If I would have gone longer, it would have been blown out like the last one was.
Yeah. And
if I would have gone too short, it would have been underexposed. Turns out this is I did with a 5-inch refractor. Focal length is 660 millimeters. The exposure time was 300 microseconds. That's 0.0003 seconds. If I would have taken
fast shutter.
Oh, it is. The Astro cameras tend to do that, and the fast shutter time allows you to take very sharp photos like this. Now, that morning I was taking this photograph, I noticed the star Spica was not too far away from the moon. Spica is the second brightest star that the moon can occult. And at best, our Aldebaran is about 20% brighter than Spica. So they're about the same brightness. So I moved the telescope over to Spica to take a photograph, and I used the same exposure time on the thing, okay? The same as I did for the moon. And there it is. Do you see it?
I don't see anything there.
On the original, I can barely make it out. Now, again, this is one of the brightest stars in the sky, the second brightest star, the Munican cult, and I was able to photograph it. Wasn't able to photograph the star at all using the same exposure. There we go, the moon, and here's this spica taken at the same exposure time. And obviously, there's a problem. If I can't capture a bright star like that, I'm not going to see 2 or 3 stars shining through a very bright moon. And this is the problem. You know, I don't think flat earthers really understand light levels, particularly talking about stars and the moon. I've been doing astronomy now for over a half century. I think I know a little bit about this by this length of time. And then I wanted to show a lunar eclipse photo I took. Right here's the lunar eclipse photo. I took this. Let's see, I'll look it up here. I took this in January of 2019. I did this with my Nikon D3200 camera. This is a 13-second exposure at ISO 1600 on the Questar 3.5-inch telescope, 1300 millimeter focal length. Now, if you look carefully, off to the upper left of the moon, you can see a star there. Do you notice that little star?
I do, yeah.
Yeah. Now that's a reasonably bright star showing up in all of this, but keep in mind this is a 13-second exposure, and the moon is pretty dim because it's in totality of a pretty deep total lunar eclipse. Now,
oh, so this would be when you don't usually see the moon. Oh no, wait. Yeah. This is a full moon in the Earth's shadow.
Yeah, and it's pretty dark. You know, yes. the flat earthers would dispute that it's in the Earth's shadow, but they would not dispute that the moon's pretty dark during a lunar eclipse. My point is, you can actually get stars around the moon at that point. And my next point is going to be, you don't usually see stars around an uneclipsed moon. If you you can see them with your eye because your eye responds differently than cameras do. Yeah. The eye responds logarithmically to light, the camera responds linearly to light. And so 9 months later, I realized the moon was full again, and it was near this night of the lunar eclipse. It was near perigee, which means it was closest to us, appeared larger. I want to do a comparison, so I took a full moon photo, and here it is, made 9 months later. Different color, you can tell there it's not an eclipse. And the exposure time on that one was 1/1600th of a second. The ISO setting was different at 6400, and so I can very quickly compute the difference. The amount of light being emitted and recorded by the camera at this point was 1,500. Well, actually, was 5,200 times more in the earlier photograph than this one. So if you can barely see stars in that one, when you reduce the exposure time and setting by more than 5,000, you are not going to see stars. So when I see these videos flat earthers make with stars supposedly shining through the moon, that's rubbish. I know it's rubbish because I know about light levels. You cannot record stars, even if the moon were transparent, because the moon is that bright. So consequently, these are not stars people are seeing. I don't know what they're seeing, but those aren't stars. They might be fake. They just might be noise.
The ones I've seen, I thought were hot pixels.
Yeah, I would be inclined to agree with you. There probably were hot pixels. All right. Any questions, comments about that?
I think that's great. It's and we have in the chat here we have Effed Up World, who is a flat earther, lives in Minnesota here, and he says he does not think the moon is transparent. So,
well, that's good. That's good. Now, again, I want to be careful. Maybe I should be very explain something. I'm not saying that all flat earthers use the arguments I'm going to talk about, but I'm finding many do. Just because you can find a flat earther here and there will say, well, I don't want to agree with that argument, doesn't mean that I don't need to address it, because there are many flat earthers who believe the moon is transparent. So, all right. Any other comments? I'm not watching the.
No, I don't think anybody's mentioned that other than Effed Up World.
Okay.
Let's see. Rufus St. Hibbins says Arwin calls it a hologram projection. So we there, yes. So I mean, I don't know if I didn't review your list closely enough to know if you're going to get back to the moon, but yeah, they say it's a hologram. They say it emits its own light. They
Well,
say it's
who's doing
recharging.
the hologram?
Clearly, it must be NASA.
Well, that means that the moon didn't exist before NASA did, or before holograms existed.
Apparently, I don't know. I don't know how it could be a hologram. Maybe it's some they reason in some sort of a projection system of some sort.
I suspect the moon's been around a lot longer than I have,
Yeah.
and holograms haven't been around as long as I have, so that would be a problem. Okay, any other comments on that one?
No, I think we're good with that one.
All right. I wanted to move on then to the claim often made by flat earthers that Polaris is stationary in the sky, that it stays fixed and all the other stars rotate around it throughout the night, and that it's always been the pole star and always will be. I see that repeated again and again and again. I'd send a video ahead for you to show. Can you show that for us now?
Oh.
Tell me to stop sharing, or
Yeah, stop sharing, and then I'll do it, and then I'll have to prep the video. Give me a second here.
okay. I'll explain this video then very quickly. I did this October 13th of 2020, so about 15 months ago. I took 277 photographs over 2.5 hours. Each one was a 13-second exposure at ISO 800 with my Nikon D3200 camera, and I had it attached to the 5-inch or 127 millimeter television refractor, again, a 660 millimeter focal length. And this gives you a field of view of about maybe a little over a degree. And in the video, you're going to see Polaris spinning around an empty spot in the sky. That spot is called the North Celestial Pole. That's the point around which the sky, at least in the northern hemisphere, seems to spin around. And I would interpret that as being the direction in space that the rotation axis of the Earth is pointing above the Earth through the North Pole. There's also a South Celestial Pole in the other direction, which we can't see here in the northern hemisphere. The southern hemisphere they can, but not here. Have you got it prepped and ready to go?
I almost do.
All right. We may want to show it a couple of times.
It isn't very long. And for people that are interested, I did put it in chat.
All right.
So they can. All right. They can watch it on their own.
Okay.
Lead.
So you can't show it on the channel?
No, I'm about to. Just a second.
Okay.
All right, and here we go. Here is they're seeing it now. You're not seeing it, but they are.
Okay. And you'll notice that there's the brightest star is up near the top left a little bit. That's Polaris. And you'll notice it's not stationary. When it runs, just rerun it again. Keep doing that until I say otherwise. And you can see that all the stars, including Polaris, are moving around a point that's a little below center of the field of view there. And this is because Polaris is about 3/4 of a degree away from the North Celestial Pole. And this is something, Mike, that anybody can check for themselves. Don't trust me. Go out and check it. That's what the flat earthers like to talk about, the zetetic philosophy, checking what you can for yourself. So I would suggest you go out and find Polaris if you can find it in the sky, and you set a telescope up. Doesn't have to be a very big, powerful telescope, and point it at Polaris and get it focused. That's important. And get it centered, and use a moderate power eyepiece. You don't need really high, but I would avoid the lower power eyepieces. Get it centered, and then walk away from the telescope. Go in the house and spend a couple hours. Come back outside, and you will find the Polaris is no longer centered. It will actually move over the course of a couple hours. As you can see, this was actually 2.5 hours, so it actually moves. Again, people can check this if they have a small telescope. They can check it for themselves. They don't have to believe me or trust me on this. This is something that is quite testable for anybody. Now, when you do the time-lapse videos with a camera, or you do a one long exposure for a half hour or an hour, it looks like the North Star Polaris doesn't move. That's because the field of view is so wide, and the small motion it takes doesn't show up. You need some magnification in order to see that. And by the way, there's another point that I want to make here with this video. When you look at it, you can see what a good focus is. Can you see how good the focus is?
Yeah, focus is a challenge sometimes for them.
And what I see many times, flat earthers put out these memes and sometimes videos where they show what stars supposedly really look like. And they use the P900 or P1000 camera. And the first time I saw one of those, I started laughing because I recognized immediately it was a bad focus. As I said, I've been using telescopes. I think I got my first telescope in 1967. So I've got some experience using telescopes. And by the way, when I first started, I didn't know how to get a proper focus myself. It takes a little practice. And I think after more than a half century, I would know what a good focus is and what a bad focus is. You know, this came up in a discussion group that you and I are in. I think before you joined the group, this one flat earther was putting up pictures like this. And I think some she had taken herself. And I said, these are just bad focuses. And I started describing what a focus is. And finally she said, well, you've got your focus, I've got mine.
Oh my gosh, it's not an opinion.
And then that's great postmodern thinking. But no, there are only two possibilities. It's in focus or it's not in focus. You can't have multiple focuses on things. And so those blobs you see, those undulating blobs of light played with P900, P1000, those are badly out of focus. And you can see here what a good focus is. You should get it focused down so the light is as small as possible. Then you'll know it's in focus at that point.
So now I noticed here also that the one that's Polaris isn't the one that's closest to the center.
No, it's not. There are other stars that are actually a little closer. Yeah, good point there. Oh, and one other thing, I think you've made a list of this yourself on your website. I've made a list too. The position of Polaris is changing. We astronomers measure positions in the sky. We call it declination and right ascension. They're very similar to latitude and longitude on the Earth. And due to an effect called precession of the equinoxes, that's continually changing. And if you look up in an astronomical almanac, which I've done over many years, going back to 1948, and you compare them every year, the position of Polaris is a little different.
So I have on screen right now the Nautical Almanac from 1900.
Yeah.
And the one from
what's the declination of what's the declaration from 1900?
The declination. There it is. 1850. It was 88 degrees, 30 minutes, 35.28 seconds.
88:30. That means it was a degree and a half off from being at the North Celestial Pole.
Yeah, just 150 years
ago. What?
Yeah.
What's 1950? What does it say for that?
1900.
Okay.
88.46.
Okay, getting closer to 89, which is a little over a degree away. Be 90 degrees would be exactly at the North Celestial Pole.
Yeah, and then 2017. I just have a couple snapshots of it.
Yeah.
2017 is 89 and 20 minutes.
Yeah, we're later on this century, the Polaris will be as close as it can be to the North Celestial Pole and will start moving away. People didn't start calling it Polaris until about 400 or 500 years ago, when it was getting within 3 degrees or so of the North Celestial Pole. And we have records of this going back. The earliest good record we have is by Claudius Ptolemy in the 2nd century AD, and it's something like 10 or 15 degrees off from the North Celestial Pole. So when flat earthers say that it's all stays stationary, you can see very clearly it doesn't. You can test that yourself, and it's always been the North Star, always been stationary. That's not true either, if you care to look into the history of the thing.
Well, they like to mention the Georgia Guidestones, which were put up in the 1980s, so all of 40 some years ago. And I don't know exactly the width of that the hole, but the angular width of the hole through which you can see it is probably a couple degrees at least, so you can't even.
Yeah, I would think so. Yeah, because right now the Polaris makes a circle with a diameter of what, a degree and a half. So it's got to be at least that in order to see it at all. That's probably going to be at least 2 degrees or more.
Yeah.
See, and so it will work for quite a long time actually, but eventually it won't if it's still there.
And we've got Effed Up World again saying, I have filmed Polaris for 45 minutes and it moves. So
very good. Very good. Well, we've got a flat earther who's actually tested it and found that his fellow flat earthers are wrong about some things. And I would challenge him, go out there and correct those people. They won't listen to me, but maybe they'll listen to a fellow flat earther. Mike, I'm always careful when I find a globe earther giving a bad argument. I will say so. In that discussion group we're in, I frequently will correct a globe brother and say, well, that's a poor argument, and tell them so. So it's important for people to police their own people they agree with.
Yeah.
I can only go so far with that.
Zumi says they'll call Effed Up World a shill if he disagrees with the.
You're probably right.
We've got PJ CNET was in here earlier, who was also a flat earther from England, who has been called a shill and banned from his favorite flat earthers for I think calling him out. And they said, no, NASA has assigned you, PJ CNET, to us, the Awake Souls, to their channel, and banned him. And PJ CNET still, love the guy, but he still is a fan of the channel that he got banned from.
Oh, that's sad.
Oh. PJ, come on.
Have you stopped showing that video?
Yeah, I did it.
Okay.
So,
well, let's move on. The next item I'd like to take on is the claim that the star's circular daily motion around the North Celestial Pole can only happen on a flat Earth. I've heard that many, many times, that it can't happen any other way, and I don't think that's the case. Let me share again just a couple of things with you, if I can remember how to do this. All right, and let's see. This is the photograph I want to show next. I took this at an observatory 2.5 years ago, I think.
Give me a second.
Okay.
I have to get the right scene. There it is. Oh, that's not.
You got it?
There it is. Yep.
Okay. Again, this is I took this with my Nikon D3200 camera. I've got the camera lens on it, not the telescope this time. It's f2.8 14 millimeter. I took this in September of 2017, so it's been 4.5 years ago now. And it's ISO 100 to 30-minute exposure. And near the middle there, you can see Polaris. It looks like it's stationary only because the field of view is so small. A little fraction of a degree isn't going to show up. That smear you see to the upper right is the Milky Way, and that structure to the right, that's the observatory where I was doing some work at the time. So you see those are pretty circular paths. If you got a ruler out and started measuring a compass, you would see they do follow through perfect circles. And the claim is this can only happen on a flat Earth. And so let's see. I've got my argument here is this. Here is my representation of what the flat Earth model looks like. You've got a round disk there for the Earth, and you got that dome over the Earth. And I'm just showing it schematically. And you've got the North Pole, and I put a dotted line above that. And you can see I have the dome spinning around that axis passing through the North Pole. That little arrow curled, that little circular arrow at the top indicates that. Now, if you were at the North Pole and looking up, then stars would make circular paths from your viewpoint. But what if you're at point O off to the right? There's an angle phi there that it makes. Would you see circles as the stars spin around? And the answer is you would not. And I'll demonstrate here when I stop sharing here why that's the case. Am I back on screen?
Yes.
All right. I have a little prop here that I use. I give a talk from time to time about flat Earth, and I use this prop for a number of things when I do. It's a little too big maybe for what we're doing here. But if you're on the North Pole of the Earth and looking up in this model of the flat Earth I just showed, then the stars would go through a circle like this. But if you're off axis, like at point O, as I showed that diagram, the stars are going to go like this. They're not going to go like that. They're going to like this. They're going to make big ovals or ellipses up in the sky. That is a fundamental fact of geometry. Let me go back to sharing screen again. And when you have a circle, and you imagine concentric circles at different heights around that dotted line axis, If you view it from the axis, those circles will look like circles, but if you view it from off the axis, they are going to be ellipses. That is a reality of geometry. You cannot deny that's the case. And to illustrate this, a couple of years ago, I went into the planetarium we have here at the, where I work at the Creation Museum, and I had them spin the stars around a spot at the top of the dome. And I set up my camera for 30 seconds and took this photograph off axis as I showed you there. And you can see clearly enough the motions of the stars in the planetarium were not circles, they were concentric ellipses. And that again shows that demonstrates very clearly that on a zetetic model, the flat Earth model most flat earthers believe today, you don't get circular arcs at all. You get elliptical arcs unless you're at the North Pole and nobody's there. So this again is something that's patently false. The person, what's his name again, who was agreeing with me several times, does he agree that this is the case, or has he commented on it?
He hasn't commented on that. He has a different question I think we can get to in a minute.
Okay.
That's off topic of this.
All right, but that's a pretty good demonstration, I think, of the problem here. And that's something I've realized all along. And I keep hearing flat earthers again and again saying, well, circular motions of the stars throughout the night can only happen on the flat Earth, and that's simply not true. It happens in the globe Earth model. It requires the stars be very far away from us. And by the way, the doesn't matter if the Earth is spinning or if the universe or the sky is spinning around us. Either one will explain that equally. It doesn't have to be the Earth moving. We have a stationary Earth, as it turns out, can explain that as long as the sky is spinning around.
I think it's, for clarity, it's not your position that the Earth is stationary, correct?
Very good. No, I'm not a geocentrist. That's a very, very important clarification. Thank you for making that. Yeah. Which, by the way, I wasn't planning to mention this. I'll just say it in passing. One thing I could add to this list is the confusion flat earthers often have with the heliocentric model and the globe Earth. They use the two terms interchangeably as if they're the same thing, and they're not. Belief that the Earth is a globe has been common for more than 2,000 years, at least in the West. However, during much of that time, the dominant belief was that the Earth was stationary, it was geocentric. That changed about 400 years ago. So you can believe in a stationary geocentric Earth and yet believe it's a globe. However, if you are a flat earther, you're kind of forced to believe in geocentrism. All flat earthers are geocentrists, but not all geocentrists are flat earthers.
Yes,
would be my point.
Squares and rectangles.
Yeah. Okay. Another claim that flat earthers often make is that the stars we see at night never change. They're always the same throughout the year. And this meme, it's a flat Earth meme. Am I sharing screen again? Am I still sharing screen?
Yep.
Yeah. This is a meme that illustrates this. There are many, many others out there. It says, why don't we see different star constellations every 3 months? It shows there, let's see, on the lower right, you got the sun to the upper left of the moon. This will be daytime if you're on the upper left of the Earth. And at night, you'd look back to the lower right. And of course, 3 months later, you'd be the upper right there. And you're seeing a different part of the sky at night. And if you go another 3 months, you're the upper left, you see another group of stars in that cone off to the left. And then finally, after 9 months from the beginning, you're to the lower left. And so they're asking, why don't we see different stars throughout the seasons, throughout the year? And the answer is, we do. And when a flat earther gives this argument, it tells me they really don't know anything about what I call the aspects of the sky and astronomy. And this too is something anybody can check out for themselves. And what I did in preparation for this the other day, I went out to the Sky and Telescope website, and I got a couple of star charts they had there, and I had to kind of shrink this down to make it fit a little bit. But on the left, I have the star chart for March 10th, which was just 2 days ago of this year. And if you look carefully, a little to the lower right of center, they've got a little nearly half full moon, nearly first quarter moon. That's where it was 2 nights ago. If you look right below that, you can see the constellation Orion. And you can see the belt stars. To the lower left of that, you can see Sirius, the brightest appearing star in the sky. Above the moon, you can see Capella. And next to it on the right is the same star chart, except a month later on April 10th of 2022. And if you look carefully, you'll see the moon on there again. It's a little left of center now. It's because this is 31 days later, and the synodic period of the moon is 29 and a half days. So it's going to be slightly to the left, a little more full than it was on the 10th this month. And if you look carefully, you'll see that Orion is shifted farther to the right. Sirius is shifted farther to the right. If you look over to the left, you can see the star Spica rising over here. I'm circling with my little
it's
pointer.
not on the left one.
That's Spica, and you can't see it over here. It hasn't risen over here in March at the same time. These are like 9 p.m. on these two respective evenings. And this is just showing the shift that takes place over the course of just 1 month. And the Big Dipper is also changing its position, a little lower in the sky, a little higher in the sky. So each month the stars change from east to west in the sky. And that's because the Earth is orbiting around the sun. And just as this meme suggested, you should see different stars every month. Well, we do see different stars every month. You know, they make planispheres. I had one I got back in 1966. I still have it. This is not it, but this is a little planisphere. And it's got an oval here representing what you can see. There's the North Celestial Pole. You got constellations on here. And you got dates and times on the perimeter here. And you spin this to get the date and the time that you want, and it will show you what the sky will look like. I can set it up for tonight. I can set it up for July, anytime I want, any time of night I want. And it does show the stars change throughout the night and throughout the year. So this claim that—
Now, is that specific to a latitude?
Yes, it is. Usually these are like 40 degrees. This one says latitude's 30 to 60. They did this by putting an oval in here. That gets you a little more room to play with.
Okay, I see, yeah.
But they're usually optimized. I would say this one's probably optimized for halfway between 30 and 60, which is 45, which is closer to where you live.
That's where I am, yeah.
But now, if you get to the equator, this won't work very well. If you work to the south of the equator, it doesn't work at all. I had a so I don't know where I got it, but I had a Southern Hemisphere planisphere, and I made a trip about a dozen years ago to South Africa with some people I know, and they had a young boy interested in stuff. So I gave him the planisphere to use. They make them for different latitudes. They do make them for different hemispheres even, but all the ones I've used have been really in the Northern Hemisphere. All right, any comments about that?
And Effed Up World, he is definitely not a run-of-the-mill flat earther, so...
That's because he's a shill paid by NASA. We know that.
Of course. And I haven't seen PJ CNET. He's in England, so it's late for him. But we've got Texas Troy just showed up, who is maybe a little more of a standard edition flat earther. They hate when they get Texas Troy. Do you like being called a standard edition flat earther? But if you have any questions, especially flat earthers, I'd love to hear them. We've got Mallory, who's more of a comedian than anything else, and she says she's a flat earther, but
well, I've seen her on your show before.
Yeah, so she's a comic genius, is how I like to put it.
So you're saying she's not really a flat earther?
Some people would say that she's just Team Skeptic with a voice changer.
Ooh. Okay. So a poet, I guess, maybe.
It could be. All right. Texas Troy has not heard anything yet, so maybe in a minute he'll have some questions after the next topic. So.
All right, let's move on to another one. A claim is often made that eclipses have been accurately predicted with a flat Earth model for thousands of years.
Oh, I love that.
I've heard that made many, many, many times. It goes back at least to Samuel Rowbottom, I do believe. And I know that Eric DeBay popularized it. It gets repeated ad nauseum by flat earthers. And I repeat, whenever time I hear this, I ask flat earthers, well, where's the evidence for this? Can you give me a citation? Can you give me a description of the method? And I have yet to have a flat earther tell me how this is done. Now, going back to Rowbottom's original work, he didn't call it this, but usually flat earthers will talk about what's called the Saros cycle. And they say that's several ancient societies found it, the Babylonians did, the Mayans in the New World discovered it independently. So it's discovered around the world independently. They say, see, this is a method you can use to predict eclipses. Well, I think it's a fundamental misunderstanding of what the Saros cycle is. First of all, you can't accurately predict eclipses with it. You can crudely do it so. And what is the Saros cycle? Well, there are two requirements for an eclipse to take place. The moon must be at the proper phase. For a lunar eclipse, that's a full moon, and for a solar eclipse, it's a new moon. And I don't think I've ever heard a flat earther dispute that fact. Okay, that only at certain eclipse phases do you get an eclipse. The other that is a necessary condition for an eclipse, but it's not a sufficient condition for an eclipse. And the other condition is a moon near a node. You see, the Earth's orbit, the moon's orbit around the Earth is tilted a little over 5 degrees to the ecliptic, the plane of the Earth's orbit, or the plane where the sun moves around the Earth, alternate, whichever one you want. And because of that, the moon is either above or below the angle between the sun and the Earth, so the shadow of the moon doesn't fall on the Earth, or the shadow of the Earth doesn't fall on the moon. It has to be close. It's like horseshoes and hand grenades. It's got to be close, but it doesn't have to be an exact match like the phase does. Now, where it gets interesting is the synodic month is the orbital period of the sun with respect to the orbital period of the moon with respect to the sun. So it's the period over which the phases of the moon repeat, and it's a little over 29 and a half days. We know it very precisely. I can give it to you like 8 or 10, so the figure's not important. 29 and a half days. And the draconic month is the orbital period of the month with respect to the nodes, the 2 points where the moon's orbit intersects the ecliptic. And it's about 27.2 days. It's more than 2 days shorter than the synodic month. So if a lunar or a solar eclipse occurs, you know that within a synodic month, one of the conditions will be met again. And with a draconic month, the other condition will be met. But since they're offered by 2 days, after 1 month, it's not going to happen. After 2 months, it's not going to happen. After 3 months, it's not going to happen. However, 223 draconic months is equal to 242 synodic months, which is 6,585 and a third days and a few minutes as well. And that turns out to be 18 years, 11 and a third days. So if there's an eclipse that takes place, there will be another one that takes place, very similar to the first after one Saros cycle. Now, the 1/3 day means it's going to happen 1/3 of the way around the Earth. Now, my first solar eclipse that I saw was in March of 1970. It was not total where I was. It was total up part of the East Coast, but I was living in Southwest Ohio at the time. And I watched it with a telescope. I had never seen a solar eclipse of any kind, so it was kind of cool. Well, 54 years later, 54 years, 1 month and a day later, that eclipse is happening again. It's going to happen in April of 2024, and it's going to pass very close to where I am now. So it's actually 3 Saros cycles later, and you can go out there and look at the website. It's Fred Esmanek's predictions hosted at NASA, and you can look at those 2 eclipse paths from March 7th, 1970 and April 16th, is it? 2020, I can't remember the exact date, 2024, April 2024. And you look at those, and my question for flat earthers is, how do you get from that first one to the second one? How do you do that with just looking the Saros cycle? I don't see how in the world you can do it. No flat earthers ever actually described that to me. And there's nothing in the literature to suggest that. You can use the Saros cycle to crudely predict when an eclipse may happen, but exactly when it happened, where it will be visible is well nigh impossible. They would, in fact, it is impossible. Flat earthers would have you believe that all the ancient astronomers did was collect a bunch of data on eclipses and then look for the periodicity and all that. The problem is you're dealing with incomplete data. Weather is going to be a problem. In the case of solar eclipses, you're not going to see most of them because you're not going to recognize a partial eclipse. The lunar eclipses, you may see half of those because you're on the half side of the moon of the Earth that's dark that you can see it. But you can have so many Saros cycles going on simultaneously, it would require Fourier analysis to tweak that out, which didn't exist until about 200 years ago. So consequently, that's not possible. The way they found it was recognizing that the eclipses only happen at certain phases and when the moon is near a node. And once they get that, then they can figure out the periodicity. So there's never any backup for that claim. It's merely an assertion I hear over and over and over again by flat earthers. A flat earther listening to us tonight, watching this program, if he wants to come out and show us, okay, here's how they did it, I would love to see that. But it's just not there. Related to this is a claim, I made it independent, but it's a related claim that flat earthers say the Saros cycle is used today on that NASA site, which is really Fred Espenek's predictions. And they say it's used to accurately predict eclipses today, and that's not the case. What they see is that there's a Saros cycle number, and then the number within a Saros cycle that's listed there. And this convention goes back to an astronomer named George Vandenberg, who in 1951 published a paper in Dutch. In 1955, it was translated. And what he was looking at was periodicities and eclipse cycles. And he'd had a beautiful graph showing this. And there are actually two other periodicities that show up. They're not as strong as the Saros cycle, but they do show up. Very interesting paper that he did. And he started this numbering conventions of Saros cycles. And so when Fred Espenek started doing his predictions a few decades ago, he just simply adopted Vandenberg's numbering sequence there. It's just a way to organize eclipses. And I think it's fascinating. Many times I will go through and I'll jump Saros cycle to Saros cycle to watch how the eclipses change. And it's fascinating. The Saros family will last about 8 centuries. It starts with there are about 80 eclipses throughout this cycle, 70 to 80, depending on which one it is. A solar eclipse will start as a partial eclipse near one of the poles. It'll then become less and less partial, penumbral eclipse, partial eclipse. Then it'll become a total eclipse or an annular eclipse. It'll work its way to towards the equator, and then it will work to the other pole. So it goes from pole to pole, either from North Pole to South Pole or South Pole to North Pole. And the path changes as it goes through this. It's a fascinating thing to watch, to see that periodicity change. The technique of actually predicting eclipses goes back to Edmund Halley in 1715. A century later, Bessel came along and improved upon that. We have, I think, what are called 7 Besselian elements. And if you look carefully at the NASA site, Fred Espenek's site, you will see the Besselian elements that are listed. And then the Chauvenet, a little later than this, Bessel improved on it slightly. And if you want to know more about that method, I would suggest this book. It's a textbook on spherical astronomy. I've got the 6th edition from 1977, originally published in 1931. I took a course in this 45 years ago. The last chapter in this book, I think it's chapter 15 or something like this, it is on occultations and eclipses. And it tells you how to predict both of those, and it goes through Bessel's method. Bessel's method covers several pages. I've scanned them and I can provide them. Yes, it's chapter 15 on occultations and eclipses. And I think this is an authoritative site. Anybody that's really interested in this ought to check into it. That is the method that's really used today. And when flat earthers claim they use a Saros cycle, it's just simply false.
So they do use it as a categorization system within when the cycles happen, but they actually don't use it to predict the details of it.
That's exactly correct.
Yeah. And I've seen many flat earthers, Austin Whitsitt loves to stand on the street and do his street evangelism, yelling out that NASA admits that they use Saros cycles instead of any, but he's never looked into it. Even he's done it in a debate. He's like, he never looked. He just parroted his Papa Flurf, Nathan Thompson.
Well, that's the problem, is that one flat earther makes a claim and other flat earthers uncritically repeat the claim. The more it gets repeated, the more it gets reinforced. And they don't bother to actually check into these claims. Yeah. I've just found that they don't believe anything I want to say to them, but they will willingly accept almost anything another flat earther says. And they're not being very Berean about it at all.
Berean.
Yeah, the Bereans in the Book of Acts, they check things for themselves. They check the scriptures, but I think everybody needs to have that attitude, and that's what flat earthers give lip service to that. You know,
constantly say, do your own research.
Do your own research, but if you do your own research, getting outside the flat Earth worlds, you might actually be surprised that there's a lot of information out there you're missing out
Um, my daughter just handed this to me. Um, I got this for Christmas from one of my sons,
on.
and
Uh-huh.
my daughter and I have been building it, and we finished it today. So she's like,
That's
"Here,
cool.
just wanted to this, yeah, stormtrooper head here, so pretty cool." Put this back here.
That's cool. How old is she?
Uh, I I don't give their ages.
Oh, okay. That's fine.
I just say that I have 33 kids, 11 sets of triplets. It was the longest 8 years of our lives. 17 boys, 17 girls, standard stuff.
Well, turns out Legos have no age limit. You find little kids, you find people in their 30s and 40s still playing with Legos, which is perfectly fine with
Yeah.
me. So
Being
it's not a,
being that I am 13 years old, I really
yeah.
do love them. So,
Oh, yeah. Well, Dick Clark they retired the claim world's oldest teenager when he died. So
oh,
I can't take that
nice.
one. So I'm content with being the world's oldest middle schooler. So,
It's nice. Okay, so we do have a couple things.
all right.
The rabbit says, Danny, I like that you're making this easy to understand for people with a basic understanding. And so thank you, the rabbit, for that. And then are you getting into the width, the size of the shadow of the eclipse as it crosses the Earth, or is that?
I wasn't planning on covering that. We can a little if you want.
I think it might be good because there's two things that are commonly brought up with eclipses. That's one, or three things: the size that they don't get, the direction they don't get, and then selenelian eclipses. So
Okay, I'm going to be dealing with the direction and selenelians next. We can come back to the other
perfect.
thing about the size. I only got two more things prepped, so we can move on to the size after that if you'd like.
Awesome. Yeah.
Okay, the another claim is that the Earth's umbra moves the wrong way during a lunar eclipse. And I think the thing is that they watch an eclipse, and let's say it starts early in the evening, and the moon is over in the east or southeastern part of your sky, and the moon is moving upward like this, east to west in the sky, because the Earth, that's the way the sky moves. And yet the shadow seems to be coming from the other direction. It seems to be coming from the lower left. The moon is moving rightward, and the moon seems to be, the shadow seems to be encroaching from the left, and that doesn't make any sense to them. And I can understand why people would be fooled by that. Again, if you watch the moon rise, it goes from left to right, at least here in the northern hemisphere, looking towards the south. It's going to go from left to right. That's east to west. And so you would think that as the moon moved, it would be encroaching on that shadow on the right side, but it comes in from the left side. So that is a point that I think people could easily be confused by. So I want to share my screen again.
Sure.
And show you something here. Let me get here. I did these series of photographs back.
It's not sharing just yet.
Not sharing it. There you
There
go.
you go.
All right. All right. I did these about 4 years ago. And what I did is let's take a look at that first photograph on the left. I went out front of my house one morning. It's probably 3:30 in the morning, and set up a tripod at the end of my driveway, and you can see my neighbor's house across the street. It's lit up by a couple of lights. And to the upper right of my neighbor's house, there's this big blob of light in the sky. I've got it labeled as the moon. The reason why it's a blob of light is it's overexposed. I already talked about the fact that getting the moon and other things in the sky at the same time is extremely difficult because you end up underexposing one or overexposing the other. Now, I've marked two bright stars in the sky. One I've indicated is Jupiter on the left, and in between the Jupiter and the moon is Spica. Can you see that on the screen there, Mike?
Yes.
Spica and Jupiter. All right. And so you got all three in the sky. Now I came back out the next morning, 24 hours later at the same time, set up the camera as best as I could in the same location at the end of my driveway, and took another photograph. And again, you can see my neighbor's house, and you can see the moon has moved, hasn't it? the moon is not in the same position. It's
Yeah.
further to the left than what it was before. That's because over the course of 24 hours, the moon is going to move about 12, 13 degrees from west to east. That's the direction of the moon's orbital motion in the sky. Now, I didn't mark where Spica and Jupiter are, but if you look carefully, you can see them too, can't you?
Yes.
Maybe not. Okay.
I can see Jupiter for sure.
Jupiter's here and Spica's right there.
Spica's not quite coming through, but
Not quite coming through. That's right. But notice that the moon is closer to them than it was the night before.
yes, yeah.
Now look at the third photograph. That was the next morning. So from the first morning to the second morning to the third morning, 2-day interval, the moon has moved further to the left once again. Now this one's going to be really hard to see Jupiter in Spica because there's some clouds and you can see kind of a halo around the moon because of those thin cirrus clouds that moved in. But you get the point. The moon is moving from right to left, that is west to east, about 12, 13 degrees a day. That's because through 360 degrees over 29 and a half days, you work it out, it's 12, 13 degrees moving across the sky. That's the moon's orbital motion. Now, flat earthers may not say, well, it's not orbiting around the earth. That's fine. It's moving through this with respect to the stars. It's pretty clear that's what it's doing. Now, what I did on that photograph on the right, it's larger size. I took that third photograph, and you can see the moon overexposed there. And I put a bright spot where the moon roughly was in the second photograph. And I put another spot where the moon was on the first photograph. And that's to let you know that on the first night, the moon was here. On the second night, the moon was there. And on the third night, the moon was there. So the moon is moving like this, right to left or west to east, as I promised you. Now, between the first and second bright spots, I put this dark circle. That dark circle is representing the Earth's umbra, the shadow of the Earth. Now, the Earth's umbra was not located there that night, but at that time. But if it were, then as the moon moved from right to left, it would have to move like this, and you will notice that it would first, in the shadow of the Earth, would first impinge on the Earth, on the moon, on the left side. What's confusing people is when you watch the moon move in the sky in the northern hemisphere, the moon moves from left to right because that's the daily motion. The Earth's rotation or the sky spinning around, it makes no difference. It's going to go from left to right. But while that's going on, the moon's also moving from right to left. And the reason why the shadow appears to be coming from the wrong direction is not is you're being fooled by that daily motion as opposed to the moon's monthly motion. And that's the difficult thing here. You have to realize there are two motions going on, one faster than the other. So the fact that the shadow impinges on the left side of the moon rather than the right side of the moon is what you would expect if the conventional explanation of the Earth's shadow falling on the moon is what we're seeing. So that's the reason why the Earth's shadow seems to go the way it does. So the flat earthers are correct when they point out that the moon's shadow generally in the northern hemisphere comes in from the left, but they're wrong in their interpretation. It's exactly what you would expect in the conventional model. Does that make sense?
It does. It is certainly a more complicated bit of three-dimensional geometry going on than you can just come in and quickly understand.
Yep.
So
I agree.
It's definitely one of the things that's understandable about for a misunderstanding for them that I can give them a little leeway on that, but then to proudly declare that it means something when they're not actually that up to date on the information, that's the problem, of course.
Yeah, and I'll grant, as you pointed out, this is kind of complicated, and it takes a little time and thought to go through the process on this one. And so I can understand why people could easily be convinced by flat earth arguments on this, but it's when you get to the close scrutiny, can you really look at it carefully and see if it really is a correct interpretation? That's the problem. And this is not an easy concept. Some of the other things I've talked about this evening have been pretty simple. This one's not. This one's complicated, but it is understandable to people who really want to spend some time to look at it and get it right.
Yes.
Any comments about that from the stream?
Well, on the bottom, there is the halo around the moon that I suspect some flat earthers would say it's the reflection off the dome.
Yeah, I've heard that a few times.
I always find it funny. It only happens certain times. If the dome is always there, it would happen all the time, I would think. Um,
Yeah.
so
All
yeah,
right.
that's a great explanation. So yes.
All right. Then Selenelians is the 10th and final thing I prepared for this evening. And when I first heard about Selenelians, um, I didn't know the term yet. It was early. I've been doing the flat Earth for about 6 years, and I first encountered this. It may have been from Rowbottom's writing about this, and I thought, what? The sun and the moon and the sky at the same time? What are they talking about? And I got the way it's written up many times to describe. It's like the moon's way up here and the sun's way up there. And if that's the case, then that is a real problem.
Yes.
So I think many times there's a misunderstanding on the part of the flat earther making the argument that gives you the wrong impression entirely. I had the wrong impression when I first read about it. But the point is, during a selenelian, which is what we're talking about, the sun and the moon are not very high in the sky. The sun is on one horizon, either setting or rising, and the moon is on the opposite horizon, either rising or setting, the opposite of what the sun is doing. They're 180 degrees, almost 180 degrees apart in the sky. And you might think, well, if the Earth's shadow is interposing there, then the Earth has to be interposed between the two. You can't see them. Well, if the sun and the moon were mere points, sun, moon, and the Earth's shadow were mere points, that would be the case. However, the sun is about a half degree across, and the moon is about a half degree across, and the Earth's umbra at the distance of the moon is about 1.3 degrees across. So if you barely have the sun sitting on the horizon in the west, getting ready to set, and a lunar eclipse was just beginning, then the center of the Earth's umbra would be slightly below the horizon in the east, but it would extend above the horizon. And the moon could be entering it really low in the sky, or vice versa. If it's occurring at sunrise, it'll be the end of an eclipse. And the other effect, and I know that flat earthers don't like to hear this, but atmospheric refraction is a real thing. And when objects are very low in the sky, like this rising sun or setting sun, it raises them up about a half degree. And that actually extends it. So when you have a selenelian, you must be at a couple of lunes on either side of the Earth, sunrise and sunset, where for a lunar eclipse where you possibly could see one. So you need to be parked in the right location. You need a very good exposure towards the east and towards the west. Any obstructions are going to be a problem. And number three, you need incredibly clear weather. If it's just kind of clear, it's not good enough. The moon's probably going to be obscured. So you need good observing conditions, and you need to be in the right place in the Earth. I have seen more than a dozen lunar eclipses, total lunar eclipses. I've seen probably another half dozen, probably another dozen partial lunar eclipses. And I have never seen a selenelian. We had an opportunity last year to see one here, and the weather didn't cooperate. It was pretty cloudy that morning. So I've never seen one. The hint, or at least the implication that flat earthers like to make about selenelians is that they're pretty common. Obviously, they're not, because the conditions need to be pretty stringent to meet both of those. And they only last for a few minutes. If you're seeing a selenelian at sunset, very quickly the sun will set. If you're seeing it near sunrise, the moon will set.
Yeah.
And so you can see a selenelian for only a matter of minutes, 5-6 minutes max, and then it's gone.
I think it's an important point, though, is we can on the globe predict where it's going to happen.
That was my next point, is using the conventional understanding of eclipses, we can predict exactly where and when someone may, if the conditions are good, see a selenelian. It's not like it's this thing that happens all the time and stumps people. People who actually go out and look for these things know what they're doing. They look for the predictions where it's possible to do it. And so again, rather than being a problem for the conventional explanation for eclipses, selenelians actually are good evidence that the explanation is indeed correct. So it's actually quite the opposite of what flat earthers want to claim.
Yeah, when I think when I spoke with Nathan Thompson on Modern Day Debate, I talked about eclipses, and rather than explain how eclipses could work on flat Earth, he deflected and said, "Oh, selenelians are impossible," which aren't. It's just another misunderstanding. Not only are they possible, but we know where they could be seen for any particular eclipse. Of course, being a large portion of the surface of the Earth is water, a large portion of where you would be able to see it is water, is covered in water. So on a ship, you might want to go get on a ship if you wanted to really see one.
Yep.
So,
Hey, you'd ask about sizes of the Earth's shadow during eclipses.
yeah.
And that's something that flat earthers go on about. They point out that the 2017 eclipse, the moon's umbra on the Earth was like 70 miles across, and they said, well, the moon's like 2,100 miles across. How can it be that small? We know that shadows are always larger than the objects casting the shadows. And they do demonstrations. They'll take a light bulb here, and they'll take a large ball, and they'll
really close.
And they put them close, and you can see that as you move move back from the shadow gets larger and larger and larger. They say, see, this proves that shadows always get larger with increasing distance away from the object. Well, if the light source is smaller than the object, that's always the case. And so this is a situation where flat earthers have done experiments, and they've reached a hasty conclusion based on one condition, the light source being smaller than the object casting the shadow. But I challenge flat earthers, try this yourself. Don't trust me, try it yourself. Get a light source that's larger than the object casting the shadow. And I did some experiments a couple of months ago. I shared them on a YouTube channel I have. Not many people know about that YouTube channel, but I took a floodlight. A floodlight is about this big around.
Yep.
And I mounted it up in my basement, and I took a wiffle ball, which is the size of a regulation baseball, and I put it on a string and held it up here. And I went back here and changed the distance, had a screen over here. And as I moved the screen farther and farther back behind the ball, the shadow got smaller and smaller and smaller as it did that. And so, I mean, I congratulate flat earthers for trying to do an experiment here, but they've only tested one possibility. There are two possibilities. You need to look at the relative sizes of the object and the light source of the thing. And it's easy to find a light source that's smaller than the object, but it's a little trickier to find a light source that's larger. And I finally hit upon this floodlight that works pretty well. I also did it a few years ago, just before the 2017 eclipse. I did it with a volleyball. It was a nice sunny morning, very clear sky, sun was rising. I had a coworker hold a volleyball up, and I calculated, I think like 42 feet away from the volleyball, the shadow of the volleyball would be half as big as the volleyball was. So I put a screen up and I measured it, and sure enough, it was half as big as the volleyball was. If you go back far enough, it'll actually taper down to nothing. And also, if you've ever noticed, if you have a large bird fly over at low elevation, you can see its shadow. If you have a plane fly over at low elevation, you can see its shadow. But you never see shadows of planes and birds flying really high in the sky. It's because the sun is larger than the birds and the planes. If what flat earthers are claiming is true, that shadows always get larger, then we should quite frequently see shadows of large birds and planes at high altitude. You'll never see that. So again, I tell flat earthers again tonight, don't believe me, don't trust me, go out and try it yourself, and you will see that I'm right about this if you do the experiment right.
Do it right. Exactly.
Yeah, do it right. So they've been misinformed on this. And I think a lot of the flat earthers that repeat this have never bothered experimenting. I've seen a couple of YouTube videos where people have done this experiment. And again, if the light source is smaller than the object casting the shadow, then the shadows will get larger. But if you use a larger light source than the object casting the shadow, you will find the shadows get smaller and smaller with distance. So since the Earth, the sun is larger than the moon or the Earth, their shadows taper down and eventually reach zero if you go back far enough. That's what happens during an annular eclipse. I've seen one annular eclipse in my time, and it leaves a little ring around the sun. And it's really a cool thing, but you need special filters to look at it. You don't dare look at it straight like you would with a total solar eclipse.
Well, absolutely. And testable.
Well, that's what I prepared for tonight, but I'm ready to talk about more topics and answer questions.
So, all right, Effed Up World, on that same topic, you may know him from Facebook. He's Joe Hill.
Joe Hill?
Joe Hill, yeah. So I don't know, he might not be in in
That discussion group we're in, I don't think
specific group.
so.
Yeah. What's the name of that group again?
Uh,
I'm in
Globe
too
Earth, Flat
many.
Earth discussion group. Yeah.
Okay, I'm in too many. I can't remember.
I'm only in one, by the way. So it's Globe Earth, Flat Earth discussion.
So he says, I have done it to scale on a 1 foot diameter globe. No 1/30th scale shadow. And then somebody asked, well, to scale, you'd need a big light source if the scaled globe is 1 foot diameter. Left Up World responded 28 feet. So I don't know what would be 28 feet.
That's a pretty big light source.
A 28-foot light source would be pretty big. And I don't know how far away, it'd have to be pretty far away. And so to do it well, you'd need to be in some sort of a large, like a barn or
I'd probably have to do it outside.
or a hangar, maybe to get the scale right.
Yeah.
Yeah. Did Ben D says for 1 foot scale, the sun is miles away.
Yeah.
So yeah, I don't see to do it really to scale is actually pretty different. Anything solar system really to scale is ridiculously hard. I remember in middle school, they gave us paper tape, just a little thin piece of paper tape. They said draw on it the sun and make it this big, and then they gave us like a quarter of an inch diameter or something. And then, all right, now here's the stuff. Figure out how far away Mercury, Venus, and Earth have to be, and that's all we did. And we had to go on the hall and stretch it way out in the hall to get. And then, of course, we didn't fill in a circle for the planets because they're like, well, a dot is going to be too big. So the scale is.
I've done this kind of thing with students many times, and I use a scale of 1 millimeter is equal to 5,000 kilometers. And on that scale, the sun is about the size of a basketball. The Earth is the size of a BB. And they're 30 meters apart, which is 100 feet. And Jupiter is one of those larger marbles, and it's like 500 feet, 520 feet away. Saturn's a little smaller model. It's 1,000 feet away, and Uranus and Neptune are regular sized marbles, and now they're like 2,000 and 3,000 feet away on the scale.
Yeah.
And the nearest star, if we're doing this in Cincinnati, the basketball here near the Cincinnati area, the nearest star, Alpha Centauri, is a beach ball somewhere near Honolulu, and that tells you something about the scales involved.
That is something. Okay. Well, I do have some questions that I've accumulated, and people, if you have any more, send them, tag me so that I see them while we go through this.
It's cheer wine time.
Oh yes. I've got my Toonshine here.
I got my cheer wine. For those of you who don't know, it's a
together maybe.
cheer wine is a black cherry soda that's bottled in Salisbury, North Carolina, and it's quite a drink. I enjoy it. It's my favorite.
Do they also make steaks there?
Steaks? No, they don't.
For TV dinners.
I think that comes out of England. I think I'm not sure.
All right, we've got a member chat from Dora Unku that says the mic is live. Let's see, and then Throw the Dwarf from the House of Torg says for 2 Australian, it must be the alien technology left here. I don't remember what that was. That the context sometimes is lost. So, well, thank you for that. Remember any alien technology context from early?
The Plastic Citizen said, we've got cheer wine in my neck of the woods.
Ooh.
I wonder where those woods are.
I've got a good one from Inquisitor. All right. Oh, I lost my thing. I'll put that at the end. It's going at the end there. Let's see. We've got Waikikamook House is pumped for the Quantum Leap reboot. There's a Quantum Leap reboot? That will be cool. I did enjoy Quantum Leap. And and then he went on to be in Star Trek. What's his name? Forgot his name. Oh, the holograms. The holograms. The alien technology from the is the holograms. Yes, definitely the hologram moon is from the alien technology from when they came here and planted us here, I suppose. All right. This is all right. So here is the Jim Tanker. And I don't know if he's a flat earther. I get the impression that he is. He asks, how can someone who works for Answers in Genesis and is supposed to believe that the Bible is inerrant not believe the earth is flat with a dome over it as the Bible describes?
And the Bible doesn't describe that.
That's easy, isn't it? Can you
Yes.
expand on that a little, I suppose, for them?
Okay. Yeah, I've said that the cosmology of the Bible is a bit vague. Uh, it doesn't say. I'd love to be a Bible verse somewhere it says the Earth is a globe. It doesn't say that, and nor you'd think if the Bible is so clearly flat Earth, somewhere in the Bible there would be a verse that says something like the Earth is flat, but it doesn't. People take passages and they try to lean on a certain meaning coming out of that. They talk about the rakia that God made on day 2. That's translated into King James as the firmament, which is a bad translation. Expanse is a much better translation there. And they try to say that that's a dome over the earth, but that doesn't mean the earth is flat at all. So there's a whole lot of assuming going on there. But the thing is, you would find in the history of the church, the majority opinion by far is that the earth is not flat. You didn't find people, for the most part, ever saying there were 2, maybe 3 people in the history of the church that said the earth was flat. And none of those actually had any traction because they were thought to be weirdos and aberrant theologians at that. Those were elevated by by Andrew Dixon White and John Draper in the late 19th century with what we call the conflict thesis. And this is where the notion that the Bible taught the earth is flat came in, but nothing of the sort was there. The Bible clearly just doesn't teach the earth is flat at all. I can understand why a person who thought it was flat would find the Bible consistent with that, but it doesn't mean the Bible teaches that. The Bible is ambiguous about the actual cosmology to a large extent. The cosmogony is clear enough, but the cosmology is a bit vague, and for good reason, I think.
Well, he did then just a minute ago then send another message as Isaiah 40:22 and Matthew 4:8. And so I have up on screen Isaiah 40:22 in a translation that I have cherry picked. The Message that says God sits high above the round ball of earth. And another translation that I cherry picked says the Peshitta Holy Bible translated says, and him who sits on the sphere of the earth. And then another cherry picking, the Dewey Reams or Dewey Rames, I'm not sure on the pronunciation, maybe Dewey Rhymes Bible says, again cherry picked, it is he that sitteth upon the globe of the earth. So I can cherry pick translations too.
Yeah, the thing is, the word used there in Hebrew refers to something round. If you ask the average person in the street, what shape is the earth? Most people would say the earth is round. And flat earthers would agree with that. They say the earth is flat and round. When most people say the earth is round, they're talking about something that's 3-dimensionally round. It's a sphere. The word round in English is a bit ambiguous in that sense. And the word in Hebrew used there is a bit ambiguous. I know 2 or 3 world-class Hebraists, and I've asked them, what does this word mean? And they say it means something round. And I asked them, does it mean a flat 2-dimensional round or a three-dimensional sphere round? And they say yes. It can mean either. And as much as I'd love to say, well, this Bible clearly says that passage clearly says the earth is a globe, as some of those translations say, and honestly, I can't say that it says that. The problem is flat earthers they want to say that means it's a round, flat earth, and that's simply not supported by the Hebrew text at all.
And then Matthew 4:8. Oh my gosh. That's, and the
The
devil
Transfiguration? No.
taketh him up into an exceeding
Yeah.
high mountain, and sheweth him the kingdoms of the world and the glory of them. Which mountain was that?
Yeah. I want to know where this mountain is. Uh, I've never had a flat earther tell me where this mountain is and even give me a proposal at all. And so until they can actually identify the mountain, I don't think I really need to answer that question.
What? I thought the highest mountain was Everest.
Yeah.
Maybe it's K2, but I don't think either of them are in Israel area.
And by the way, Mike, I have written about this quite a bit. I have a chapter in this book that you mentioned before, and I also have articles on our website, answersingenesis.org, where I've dealt with this. I've got about 30 articles and blogs on flat Earth there, in addition to the book. So I've dealt with a lot of these biblical arguments before.
The link to that blog is in the description already.
Yeah.
And once more, the Jim Tanker comes in with, in Hebrew, it is circle, not ball or round.
That's not true. Again, I know several world-class Hebraists. One of them got his PhD from an institution across the river here at Hebrew Union, which is arguably the most prestigious Hebrew school in the United States and possibly the world. Another one I know got his PhD, I believe, from Cambridge or Oxford, one of the two. The little upstart institutions in the UK you may have heard about.
Yeah, they seem familiar.
Yeah. So I asked these two fellows. I know other people too that know Hebrew quite well. These are Hebraists. They're just not Hebrew speakers. They really know Hebrew. To be a Hebraist, really, you need to not only know Hebrew, but you need to know about a dozen other ancient Semitic languages related to it, so you can work out the cognates and so forth. You need to be proficient in German as well to work the lexicons and the other sources there. So it's not just a matter of picking up a lexicon and try to work your way through it. These guys really know what they're talking about, and it means something round.
And Nuriel, who is not a Hebraist, is that what you said?
Yeah.
Or he has a channel, the Round Thinker. He's active on Facebook. He's born and raised in Israel. His first language is Hebrew, and he has said that the understanding of that is, rather than Earth is round, it is more appropriate to understand it as Earth has the aspect of being round, the traits of being round, as does a sphere. So, okay. A completely off the topic one I thought I'd put in right now. PJCnet, he thinks that the entire universe, I think he really puts a lot into this, that it is a simulation. He's a simulation theory guy, and he uses that to as his get out of jail free card for anything that doesn't match. But Pilo,
is he a flat earther or a globe earther?
He's a flat earther. He's the one that got banned from the Flat Earthers channel because they think that he's the NASA shill assigned to them.
Oh, okay, yeah.
So Pilo 1408 says the flood is a metaphor for the simulation server getting flooded with ping requests in a massive distributed denial of service attack. So there you go. I think that's a great simulation theory explanation.
I like that.
I have to deal with DDoSs at times. So,
Sure.
Have you heard of? Do you know of JM Truth?
I've heard that, but I don't know much
Joshua
about James.
Michael. He claims that Hebrew is the first language.
Oh, that's a common belief. I've encountered that many times. I have friends of mine who are on either side of that issue. So I don't necessarily believe it or reject it. I just think that it's maybe an attempt too much. I think the argument people are making from Scripture is that there is some implied meanings in Hebrew names that are found early in Scripture before the Tower of Babel in chapter 11. Like some of the patriarchs' names, they think that those have meaning in Hebrew, and they wouldn't have meaning if there was some other language prior to that. I think that's the main argument for saying that Hebrew was the original mother tongue from which all of this branched out. I think linguists, and again, really world-class linguists who are Christians and take the scriptures very seriously, have a difficult time with that one.
Okay. We've got from Effed Up World / Joe Hill again, coming in with what do you think about Jude 1:13? And I'll give the trend the read that out. The
wandering stars.
They are wild waves of sea foaming up their shame, wandering stars for whom blackest darkness has been reserved forever. That's great poetry sounding to me.
Well, yeah, they're talking about the wild waves there, and they ignore that part and go right to the wandering stars part and think that that has to be literal in some sense. And I'm looking, well, look at the first part of the passage. It's talking about something else. Which is it? Are they wandering waves or are they wandering stars? Which one are they? So you got to be careful on that one. If it does refer to the wandering stars, the planetas, Aster, what planets, or is it referring to meteors? Commentaries are all over the place on that. And I think by looking at that, people miss the point of the passage. It's a warning against these false teachers, is what it is. And I think they're missing the main point by looking at the specifics of not the main point.
Right. So we've got the TT guy has asked several times in different ways, and I picked up this one of the couple different times. So Danny knows that the Bible is using metaphor about the dome, but not metaphor with creation story. So that's the cosmogony difference again.
I don't think I ever said metaphor with the dome. The word dome doesn't appear in Scripture. I think that's a misunderstanding. People think the word rakia is a dome, and it's not what the word means at all. It's just completely wrong to say that that's what it means. So there's no metaphor involved whatsoever.
But I think more to his point, and I think is he is talking about taking literally, flat earthers take literally things that suggest to them the shape of the earth, and comparing it to taking literally things about the age of the universe.
Yeah. And I get that, and I understand that. I think one difference right off the bat is we do make a distinction between experimental observational science and historical and origin science. And the question of what the Earth's shape is a question that we can ask right here and now about the universe, because we're not asking what shape the Earth was a million years ago. We're asking what shape is the Earth today. When you start talking about past processes in the universe, you can't test those ideas the same way we can test things in the here and now. So there's a big difference. And by the way, that's one of the reasons why I'm on the case working with Flat Earth, because I think people are trying to blur the distinction. I suspect that some people out there promoting Flat Earth are doing it as a vehicle, as a literary device to speak about recent creationists as I am, saying, well, you people are using the same arguments that Flat Earthers are using. I say, no, we're not using the same arguments. And so I'm quite well aware of the fact that people want to make that parallel, but I don't think it works at all.
I do see myself, I see some overlap, but that's not this discussion.
That's right. We can have that another day.
Yes. And like I said earlier, in chat, in comment here, this is like a presentation, not a debate. And I want to have any view on here for that to come in and present, and specifically views that I don't agree with, like Eric Hovind, I specifically have invited on.
Has he been on your show?
He has not. And I don't think he does debates. His dad does. I totally disrespect how his dad does debates, and he could not be on this show because he cannot behave in a manner that is what this show will support for a
I know both of them, and Eric and Kent are not the same people.
I
So
met Eric in person in Florida in April.
you
Or
told
not
me
April, in
you
January.
posted the photo about the two of you meeting.
Yes, and
You sent it to me at least.
what a great guy, a great fun conversation. He brought me, and my kids were playing with his dog in the what used to be Dino Land, and we went into a studio and we talked about flat Earth.
Oh, wait a minute. You can go to his place, but you won't come to our place.
We were camping seriously about 20 miles from there. So
Oh, we have campsites near here too.
all right, well, next
By,
time.
by the way, just off the subject, but you mentioned this. I was watching Owen Benjamin's presentation at the. It's pretty bad, I
Oh,
know.
he's terrible.
It is, but I just noticed some of the mannerisms in his speech patterns reminded me of Eric quite a bit.
Of who?
Eric Hovind.
Oh, really?
Just some of the mannerisms and the way he spoke, Owen Benjamin did without the profanity, reminded me a little bit of Eric in some respects. So it was interesting. But yeah, Eric's a good guy. We're good friends.
Okay. Texas Troy, who is the flat earther that's described himself as an intelligent flat earther. He didn't want to be a standard model of flat earther.
Yeah.
He says maybe he can explain why we can see the moon and sun in the sky at the same time.
Oh,
It's,
that's it's a common problem. People seem to think that the moon is only out at night, and it's not, because it orbits around the Earth once a month. It spends half the time in the sky with the sun. On average, when the moon is new, it rises with the sun and sets with the sun. It's up all day long. The problem is you can't see it because it's not very bright. It's too close to the sun. When the moon is at its brightest, it's full moon, but it rises when the sun sets and sets when the sun rises. So they're not in the sky at the same time. But a couple of days ago, the moon was first quarter. Tonight, it's a couple of days past. It's a waxing gibbous, and it rose mid-afternoon, and it was up from mid-afternoon, probably 4 hours at least, with the sun this afternoon. If you were out and paying attention to it, you could see it where I live because it was clear enough then. So people many times just never notice the moon. I've had adults that were out and they saw, say, the third quarter moon in the early morning sky, and they said, "Whoa, what's the moon doing out in the daytime?" I think it's really weird, but it's really up much of the time, believe it or not. You just never noticed it before.
yeah.
And they're trying to show that it's going to be very difficult because it's a three-dimensional sort of thing. And I think it's best, if somebody wants to see that, I need to sit down or walk around them with props and stuff. But trying to do it on a YouTube video is next impossible.
Maybe if they went and found themselves an orrery.
Mm-hmm. That would help.
So an orrery is actually a three-dimensional model. People have probably seen them, where you've got the sun, the earth, and the moon, and like you turn a crank, and like the moon rotates around or orbits around the earth, and then the earth orbits, I don't want to get them wrong, orbits around the sun, and you can actually see that happening in 3 dimensions. And
well, one thing I try to get students to do, and I think I'd like to get more people doing, is to observe the moon throughout a month. Right now, the moon is approaching full moon, but it's good to do it in the evening when the moon is a crescent, which would happen in about 3 weeks, and just go out at night at a certain time, right after sunset, and look where the moon is in the sky. Maybe even sketch it. It would be a thin crescent. And then the next night, get in the same spot at the same time and look at the moon, and it will have moved from right to left in the sky for people in the northern hemisphere at least. And the crescent will be a little thicker. And the next night, a little thicker and farther to the east and to the east. And over the course of 2 weeks, it'll go from a thin crescent in the west to a full moon in the east. Then if you get up in the morning before sunrise and look for the moon, the same thing will happen in reverse. The moon will be full over in the west, and it'll get less and less full, going back to a waning crescent. And if you watch the moon over the course of a month or two like that, you get a very good sense of the moon's motion, what's possible. You can even make some inferences about what causes lunar phases, And you'll also notice that the moon will be in the sky in the daytime, a part of the time, but most people aren't looking. That's the problem. So when flat earthers never, like most people, they don't know that the moon can be out in the daytime. So one day they happen to spot the moon in the sky at the same time. They say, wow, that can't happen on a globe Earth. So therefore the Earth must be flat. And that's just some of the sloppiest reasoning ever.
It's even worse because so many of the flat Earth models I've seen, they have the moon and the sun opposite each other the whole time. They never even bothered. Like they've updated that, but some of them still have them opposite each other.
Yeah.
So I think that's funny. Okay, Texas Troy. Mr. E Man says, when Texas Troy provides his proof, will you please make a video? I must go now, but I'm on pins and needles. Texas Troy has been saying he's apparently he's gonna come on. He's gonna come on the show at some point here and present something. It should be great. Okay. Effed Up World, Joe Hill says something to maybe run by him. This isn't a question, it's just a statement. I don't think there is any conspiracy. Again, an odd flat earther. He says, we don't struggle against flesh and blood. So that's a...
Okay, well, wait a minute. I'm curious. He's a flat earther, but he doesn't believe there's a conspiracy?
He thinks that satellites exist, that people went to the moon, that rockets do go up somewhere, but somehow he thinks once they go past a certain speed, they're in a different realm because of the velocity.
And do people who've been to the moon know the Earth is flat, or do they? What's going on with that?
I don't know. I think that his position is that people are confused then.
Okay.
Somehow.
Well, this brings up a very good point, Mike. We generally tend to think of flat earthers as being monolithic. They all believe the same things.
And clearly they don't. Yeah.
And over 6 years, I've discovered just how diverse that they are. They're united around one concept: the Earth is flat. But then they're beyond that. There's a large amount of disagreements, and so trying to nail down what the flat Earth position is on some things is well nigh impossible, because you can always find a flat earther who will say, "Well, I don't believe that," and they can be very earnest about it. And the fact that they're condemning each other for being shills is another indication they're not very united at all, except on one point and one point only, which is really strange when you think about it.
Yeah, their disdain for the Flat Earth Society is funny. They're like, the Flat Earth Society is just trying to make us look bad. I'm like, you don't need help.
But on top of that, how many of the things at the Flat Earth Society website would they disagree with?
I think a lot of them they don't. Generally, it's just gravity.
I think the only thing is that I can make out is the argument about gravity. I think the Flat Earth Society has the Earth accelerating upward at 9.8 meters per second squared.
It's not even a consistent thing. I've been on their forums, and there's actually, there's different tribes. There is the flatearthsociety.org and tfes.org. There was a schism back a while before 2015 even, and they formed separate websites. That schism was so so dire, and so it's mostly just a forum, and there's 2 or 3 people at tfes.org that actually maintain the Wikipedia site. That's it. 2 or 3 people. And I interviewed one of them on here 3 years ago, Pete Savarier. And it's just him and Tom Bishop mainly that neither are their real names that do that. And so the other people on the forums that are flat earthers don't necessarily think that it's an upward acceleration. So again, there is no consistency even within the Flat Earth Society.
And when mentioning gravity, when it comes to the outside, away from the Flat Earth Society, there are 2 main schools of thought. One of them is following Bob Nodell's idea about what's the term he uses, non-something or other. What's the term? I can't remember.
Incoherent dielectric acceleration.
That's it. And then the other one is just density and buoyancy. And I don't know if any other. There are probably other variations too, but I'm not aware.
There incoherent dielectric acceleration is just word salad.
No, it's truck speak, techno babble.
And it comes primarily from Ken Wheeler, who is not a flat earther. But there are others. There is the upward acceleration. There is the infinite plane, which actually is sort of like in the realm of maybe possible, except it would be incredibly unstable.
If you're thinking about in terms of, well, you came from electrical engineering, I believe, and if you do an infinite sheet of charge,
yes,
with a uniform density of surface density of charge, then you only have the electric field that's everywhere perpendicular like this. And so with some sort of gravitational attraction on an infinite plane, you'd get the same thing. Again, it wouldn't be stable, but you would get the same sort of thing. Which that works. You're accepting gravity as we generally understand it, with throwing everything else away. But those are minority viewpoints, I believe.
Yep. And then it doesn't explain the variations in gravity, and it would not be stable, so it would collapse into a sphere anyway. Yeah. The other one that is actually it's crazy, but it's maybe has the most like explanations that work would be that the Earth is on like some sort of a platform suspended by cables or maybe pillars to a pivot, and it's spinning around, and centrifugal force is what's doing. And there's a Q Tuttle, I think, is on YouTube, one guy that promotes that particular idea.
This sounds almost like a variation on concave Earth, doesn't it? Or hollow Earth.
Well, concave, they don't think the Earth is moving either, concavers.
Right.
They think they come up with other crazier stuff, but that he's the only one I know of, Q Tuttle, if I'm remembering his name right. He's the only one I know of that actually thinks that's the explanation. I'm like, that's the best one. But it's moving, so the flat and stationary people don't go for that. Okay. Texas Troy, now he's upset, as many people are, that Pluto's no longer a planet. So why was Pluto booted as a planet? As a science and astronomy enthusiast, I find that Pluto does in fact qualify as a planet.
I was in favor of demoting Pluto long before it was cool. I was telling my students way back in 30 years ago, I said, you wait until Clyde Tombaugh dies, and there will be a movement to demote it. And the argument basically is Pluto's too small. We didn't know the mass of Pluto until 1979. We knew the mass of Pluto was small from its discovery in 1930, but in 79 we found out it was even smaller than we had thought. It takes about 400 Plutos to equal the mass of the Earth. It takes, what does it take? The number escapes me off the top of my head, but it takes quite a few of them to match the mass of Mercury. Yeah. So there's obviously a big gap there. And we have discovered some rather large objects out among the trans-Neptunian objects, of which Pluto is one of the larger. We found Eris almost 20 years ago. And for a while, we thought it was slightly larger than Pluto. Now we believe it's only slightly smaller than Pluto. And so if Pluto's not a planet, why shouldn't Eris be a planet? So forth, on and on it goes. You need a dividing line somewhere. And if we don't stop at, say, at Mercury, then you're actually at the prospects of having hundreds or thousands of planets. There's an obvious gap there between Mercury and Pluto. So why not capitalize on that gap? The other thing that the astronomers never talk about is the fact that we can divide the planets into two groups: the inner four planets, which are called the terrestrial planets, and the next four, which we call the Jovian or gas giant planets. And they have several characteristics. I think I've listed 7 when I teach this. that the 4 and the 4 have in common with each other. But if you try to include Pluto in that, it's all over the place. The motif doesn't fit
Yeah,
at all.
it's not a gas giant. It's not.
Except, well, it depends what characteristics. Its density is such that it would be a Jovian planet. It has 5 satellites, which would make it a Jovian planet. It's far from the sun, which makes it a Jovian planet, but it's very small, which makes it a terrestrial planet. It rotates very slowly, which makes it a terrestrial planet. So it's just haphazard all over the place. So there are at least 2 good arguments I can give for this. And again, I was against Pluto 30 years ago, before it was cool.
So I've heard, and this is the one that I thought made the most sense, that it did not clear its orbit of other debris for the most part.
Well, that's the third part of the definition of a planet that the American Astronomical Union, International Astronomical Union, adopted in 2006.
And that's what tipped it over.
And that was the official declaration. But that third, the thing is, a planet has to orbit the sun. It has to be spherical in shape, and it has to have cleared its orbit. And that was problematic. They're trying to be too clever by half at this point. Which planet has cleared its orbit? If the Earth had cleared its orbit, there wouldn't be any near Earth asteroids. Now, would there be? So the Earth hasn't cleared its orbit either. So it's kind of a judgment call. How much clearing must there be in order to be cleared? And I really don't like that third criterion that the IAU adopted in 2006. And I think it's problematic. It really is.
Interesting. That's the one I thought made the most sense. All right. Okay. Inquisitor Rurik says, this is off topic, but I'd like to know his take on the Fermi paradox.
Yeah, I've written about that a little bit.
Maybe
the Fermi paradox,
background, yeah.
Yeah, Fermi paradox was coined 70 years ago by Enrico Fermi. He was having a conversation with 2 co-workers at Los Alamos, one of the labs out west he was working at, over lunch, and they were talking about ETs. At that point, there was a lot of discussion, particularly since there had been UFO sightings had been in the news the previous 5 years or so, and people were quite abuzz about this. And Fermi just in the middle of the conversation just blurted out, "Where are they?" And his argument was that, well, look, we're about to enter inner space. People in 1950 knew that we were soon to enter space. And you can presume that if we're not alone in the universe, there are many other civilizations. There would be civilizations ahead of us in technology, and they would have already conquered space. And there was, even today, there is no clear indication that aliens have ever visited the Earth. I'm sorry that people that think otherwise, but show us the evidence. It's a bunch of vague stuff that I think is at best questionable. And so Fermi was asking, well, if aliens are out there, why haven't they come yet? And to me, that's a very good line of evidence that indicates that there are no ETs out there. So I have written some about that, some on our website. If you go to answersingenesis.org and just simply search for Fermi paradox, you probably would get one of my articles where I discuss that. And I've also written, one of my books I've written is what we call a pocket guide on UFOs and ETs that we sell at Answers in Genesis. And it's like a 100-page book. And I talk about the Fermi paradox in there.
Very cool. I always like that one. That's a great one.
Yeah, it's a great question.
So the TT guy again, he says, how does Danny decide the creation story is literally true?
Well, because from the context, from the language being used, it's what we call a historical narrative. People get really concerned that there's figurative language, allegorical language, metaphorical language, poetic language used in the Bible. Some Christians are afraid to admit any of that, which I think is ridiculous because it's pretty clear. And those kind of allegorical and symbolic things are really found in poetic books and the prophetic passages in Scripture. However, those are largely absent from the historical narratives, and telling the two apart is not very difficult at all. You can tell what historical narrative is, even in English translation. It's even clearer, I guess, in original Hebrew, the Old Testament. And so when we read Genesis, it appears to be a historical narrative, and many biblical scholars who don't believe it's inspired text at all agree on this. They will say the writer or writer of Genesis 1 was very clearly laying out just pretty much what the text says, that God created the world in six normal days. It's only people who somehow want to save the Bible from the conflict it has with what some people say about the history and the age of the earth and the world around us that do all sorts of handstands and dancing around to try to get it to say something other than that.
Well, on a similar note, the Jim Tanker again says, it was asked before, but please ask how old the Earth is.
A few thousand years old, I'd say really press about 6,200 years. And I base this upon biblical chronology and genealogies found in Scripture.
And then, okay, as long as we're on this topic, I'm shuffling the order here from Ray.
I knew we'd end up there eventually anyway.
Of course, yes. Raybot one. It certainly overlaps in some, cosmology, cosmogony. Before this, had never heard the word cosmogony before. So, Raybot one.
Do you want me to find that term for you?
No, I know what it means now.
Okay.
But
okay.
Yeah, well, maybe for our audience, it might be good.
Okay. Cosmology is a study of the structure of the universe. Cosmogony is a study of the history and origin of the universe. So technically speaking, the Big Bang is not a cosmology. It's called that all the time, but it's really a cosmogony. Whether the Earth is flat or a globe, that's a cosmology. Whether the world is geocentric, heliocentric, that's a cosmology. But a cosmogony deals with the history and origin of things.
All right. So Ray Botts then says, can Dr. Faulkner explain how the Earth can be only 6,000 years old, but we can somehow see light from stars millions of light years away?
Yes, I can.
Could you do it, please? For me, all right, the rabbit just asked, how old do I think the world is?
Yeah.
I think about 4 billion years old.
Yeah.
That's my position.
Yeah, well, we disagree on that, and that's fine.
Yep. And this isn't I agree with Danny on everything, of course. And I talked with Craig. Craig isn't here because he's feeling under the weather. He would have maybe been here otherwise, but he just wanted
to dodge talking to me. That was all.
No, I don't think so. He's not in the chat.
I don't think so either. I've never actually met him. I've kind of messaged him a couple of times, but he's an interesting guy. We would disagree about a lot, but we would agree on some stuff too. I'd love to have a conversation with him sometime.
And I said to Craig, look, Craig, if I were to only have people on that I completely agreed with, that our Venn diagrams of things overlap, I couldn't ever have anybody on but me. And my audience would be me. My wife wouldn't even be in the audience. So
let me answer the question for you. I mean, I was being just smart there for a moment to amuse you. We call this the light travel time problem, and indeed is a problem. If I were going to make a case for a billions of year old universe, that's where I would go probably to make this case. But before I launch in that, keep in mind that the Big Bang cosmogony has a light travel time problem too. It's called the horizon problem. And it was recognized 50 years ago. And they developed 40 years ago what's called cosmic inflation to explain away that problem, even though cosmic inflation has no evidence to support it. It's necessary. What I mean by the horizon problem is you look at the cosmic microwave background, CMB for short, you look off in this direction, 13.8 billion light years, and you can measure the temperature. And you look off in this direction, opposite to that 13.8 billion light years, and they can measure the temperature there. And the temperatures of those 2 points are the same within one part in 10,000 or 100,000, excuse me, very precisely the same temperature, even though they've never actually exchanged energy with one another. In order to come to thermal equilibrium, you have to exchange energy, radiation mechanism here. So why is the universe all the same temperature if the Big Bang cosmology is correct? And they hypothesized the cosmic inflation largely to explain how that could be. And the argument is that early on in the universe, like 10 to the minus 34 seconds or 35 seconds, the universe went under this very rapid inflation prior to that, the universe was very small and came into thermal equilibrium. Then it got pulled out of thermal equilibrium, but it bears testimony of that fact that it was in thermal equilibrium at once because it all has the same temperature and is just now gradually coming back into thermal equilibrium with itself. That's the argument. Again, there's no evidence that it's the case. So if you're going to press me on evidence for what I'm about to tell you is correct, keep in mind that people who believe the Big Bang cosmogony have a similar problem that are explaining away in a similar manner that I do without any evidence for what their rescuing device is. I note that on day 3, God did not just instantly make the plants. If you read very carefully how God describes, he made them, he caused the plants to grow up and mature. If you look at the wording there, I think in verses 11 and 12, and you find this again and again and again. God didn't just instantly create things out of nothing, though ultimately the creation was out of nothing, actually helo. God used a lot of process. God made man out of the dust of the ground. He made the land animals and the birds out of the dust of the ground as well. He made Eve from his side. He made the plants to grow out of the ground. God does this again and again and again. And several times in the creation account, he says what he made was very good. At the end of the week, he says it was very good. And this goodness refers to the completeness. The description of the world when God first makes it in verse 1, in verse 2, he says that it was unfilled and unformed. He wasn't finished with it yet. He took 6 days to form it and finish it and fill it. And that's an idea of completeness. Things were fulfilling their functions. Why did God rapidly grow those plants out of the ground? Well, because according to verse 30, everybody was an herbivore at the very beginning. They needed the fruit of those plants in order to survive. And God did this through a miraculous way, a very rapid growth out of the ground. I think on day 4, God did the same thing with the stars. He created the distant bodies in the universe, and then he rapidly brought the light to the earth, just as he caused the plants to grow rapidly out of the ground on day 3. And this is because without the light being visible, the stars could not fulfill their functions that were given to them. And so the very good could not be pronounced at the end of the creation week. So what I'm proposing is that God performed a miracle on day 4, but you know what? The entire creation week was miraculous. Some of my creation science brethren like to explain away the light travel time problem with a physical mechanism on day 4 or since, but that's the only example of a naturalistic explanation we would find in the entire creation week. I think they seriously underestimate just how miraculous all the creation week was. In a nutshell, that is my explanation. If you want to go more, you can look at some of my writings. Again, you can go to the Answers in Genesis website and search for my solution. I've called it the Dasha solution, D-A-S-H-A. If you look for that word at the website, you'll find where I've written more about it.
Excellent. And the chat did go on that one there, and the TT
I imagine
guy,
it did.
the TT guy kept asking a few things, and I think that you gave your answer to him, and you do.
And this is getting off the subject we were talking about tonight. If we want to come back and talk about this more, maybe I could do that.
That's my point. Because I've had a few different evolution creation Age of the Universe debates on here already, and I intend to have more. I think it's a fascinating topic.
And by the way, I anticipated that these kind of questions would be asked tonight, so I wasn't like I was surprised to hear them. Again, I prefer not to talk about them because we're here to talk about a different subject. We can talk about a lot of stuff here. We can talk about Ukraine, we can talk about politics, but we're not going to talk about those because we're here talking about something different tonight.
A good friend of mine, he says similar thing to what you did there, and I'm like, dude, it's just last Thursdayism. What are you doing to me? But all right, let's look it up if you don't know I'm talking about people. Okay. Let's see. We've got if the Bible is only for Hebrew speakers. I don't know who asked this. I'm sorry. Why has it been translated to so many other languages? Why does the only Hebrew speaking nation on earth not embrace it as their constitution? That's far out there.
Well, the Bible isn't written just in Hebrew. The Old Testament mostly is, but there's a little bit Aramaic. But the New Testament is written in Greek. So it's 2 or 3 languages we're concerned with. but I guess I didn't understand the question anyway.
Um, why has it been translated to so many other languages? Yeah,
Well, because I can't read or speak either one of those languages.
yeah.
So I need help.
Oh, the Jim Tanker says to me, "So you." I think he hit enter to. Oh, there it is. So you're not going to ask my question. No more money. What? I did ask your question. I don't know what one I didn't. Hold on. Oh no, there it is. Dude. I have a backlog. I, I generally cover them in order. So there's two more and then yours, Jim. So it's fine. We Jerry 1SM says, or we Jerryism says, I gotta say, no disrespect intended. I can't reconcile science with religion. Me neither. I think they're separate things. And so, all right, Texas Troy says, have we had the topic of how measurements of distant objects are formulated? We have not. Not tonight, but I have covered it briefly in some things. I think that's a good question, though. How was the distance to Polaris measured?
Okay, I have two rather lengthy papers on the Answers Research Journal, which is hosted on the Answers in Genesis website. I believe the titles of the paper are Astronomical Distance Determination Methods, Part 1 and Part 2. Part 1 is primarily in the solar system, and then we move on to stars beyond that. So it's there's not a short answer to all of these, but just to jump ahead, talking about, since he asked stars, Polaris in particular, the basic method we have, and the only direct method we have of measuring distances of stars, is through trigonometric parallax. This is something, by the way, that on my list of things, I think it's on my list of things that flat earthers say is not the case. Number 14 on my list, there are no measured parallaxes of stars. That's false. The first parallax measurement was done by Bessel in 1838. It's not an easy measurement because the angles are very small. The closest, let me go over what parallax is. If you hold your thumb up at arm's length like I'm doing now, and you look at your thumb with one eye and then the other, your thumb seems to shift back and forth. Now, if you have somebody stand across the room and hold their thumb, it's not going to shift as much because your baseline is less. If the sun's right here between my two eyeballs, and this is one side of the Earth's orbit, and that's the other side of the Earth's orbit. It goes around every year, 6 months, 6 months on one side or the other. And my thumb's a star, then you get an idea of the shift that takes place. That's a basic fact of geometry, that if you change your position, as we do every 6 months as we orbit around the Earth, around the sun, then stars will shift back and forth in the sky. This is one reason why the ancient Greeks rejected the heliocentric model for the most part, because they didn't see parallax. They knew it would happen if the heliocentric model were correct, and they didn't see it. So they're good scientists and they rejected it. The point is, stars are extremely distant. The nearest star is so far away that its parallax is only about 3/4 of an arc second, which is like the diameter of a dime held up at 2 miles. That's an incredibly small angle. And it's no wonder that it wasn't until well into the 19th century people measured it. And that technology improved until the early 1900s. They were able to measure with 20% accuracy stars out to about 60 light years or so, and that got them scores of stars. Things really changed, though, 30 years ago with the Hipparcos mission launched by the European Space Agency that extended out reliable measurements by 20% out to about 600 light years. Now we have the Gaia mission, which is doing the same thing again. It's an ongoing mission right now, except it's being able to get parallaxes to 20% accuracy out to about 6,000 light years, millions of stars. And then we can use those distances, the measured of stars, that way to calibrate the other methods we have, indirect methods, such as Cepheid variables and several others that I could mention. Polaris is close enough. It's a few hundred light years, several hundred light years, but it's close enough that the Gaia mission has measured its parallax. And so we now have a parallax measurement directly for Polaris. We didn't have that 10 years ago, but now we do. So that's the real short answer on all of that. But so when people say we know the distance to a star within a few hundred light years, I think we know that distance pretty accurately today. When you start getting out to galaxies, well, I'm depending how far away it is, it might be as good as a few percent actually, which is not bad for measurements. I love this how flat earthers deal with this. The question mentioned Polaris. And I've heard Bob Nodell and others talk about this. Bob Nodell talked about it not once, but twice, at least twice at the FEICs. And he was talking about the variations in the distances. People would measure this distance, somebody else measure that distance. And he talked about how they're off by trillions of miles and, huge amounts. But that's not the way you make appropriate comparisons. It should be done on a percentage basis rather than a linear basis.
It's just an attempt at denial.
Yeah, don't understand error analysis. That's the problem. Percent difference is a much better way to compare those things. So not a problem. I hope that answers the question as quickly as I can. Again, if you want to know more, just go to our website and look up my 2 papers on that and read through it. It'll take you a while.
All right. The Jim Tanker, again, says, what about the, and then I'm going to mispronounce this, Göbekli tape, TP, TEPE, which has been dated to approximately 11,000 years old.
Yeah, that's an archaeological site in the Middle East.
Okay.
I don't know the nature of the dating method. I'm going to guess it was radiocarbon dating, but I don't know for certain. I've not looked into that enough, but I know about I think it's in Turkey. I think where the archaeological site is, and it is considered, I think, today to be the earliest, oldest actual dwellings or city, if you will. And I believe the radiometric dates are probably in error.
Okay. That's not your field much, is it?
It's not my field, exactly. Good point. Thank you for pointing that out. And again, it's not what we've been to talk about tonight, but I don't mind, people asking those kind of questions, but I don't want to spend a lot of time on it because it is out of my field.
Who would somebody, you think, at Answers in Genesis be willing to come on for that discussion? That is more, or maybe not even an Answers in Genesis. Maybe we can discuss offline who might be the person to have these questions.
Yeah, I would not be comfortable talking about those kind of questions, but there are some people where we could talk about some possibilities later on.
Yeah.
Now, we don't want to do it publicly, but privately, I would.
Sure.
Maybe make a couple. I got a couple ideas in mind for
you. Okay. That is, all right, that's the end of the list I have there. Let me make sure I got, and I got a pronunciation pronounced Tepe, maybe? Tepe?
Yeah, I know what you're talking about, though.
Yeah, okay. All right. I want to make sure I didn't miss anything. And,
I do see somebody saying this guy should have his PhD taken off him.
So somebody's asking about what Craig and I thought, because we did have a conversation about this, and in the end, Craig and I were both in agreement that this is a great topic, and Danny is a great guest to have, and when it comes to flat Earth, hey, we're all in agreement. And when it comes to other things, myself and Danny, myself and Craig, you in the audience, and me, we all have differing positions on everything. And we can't slice off everything that we don't agree with, because we end up alone, outstanding in a field, abandoned by everybody. That's a JM Truth reference there. So,
somebody says I look like Richard Dreyfuss. Yeah, I've heard that many times. How do you Richard Dreyfuss is an actor, so how do you know I'm not Richard Dreyfuss? Just pretending to be Danny Faulkner.
Could be. I've I mean, Kyle Adams.
Oh yeah.
And Kyle challenged me in video to do a back and forth video debate a common
Yeah,
ground debate, as he said.
on the moon landings.
Exactly. And my question, my response to his first video was, well, before we do that, I just need to know what you will accept as evidence, because he had already rejected photographs and video and personal testimony. I'm like, all right, well,
Yeah.
what will you accept? And just to be clear, Kyle, I'm going to expect that you consistently apply that standard of evidence to everything, including, he's a Mormon, his position on whether or not Joseph Smith even existed. Because all we have is, we don't have, I don't know if there are pictures of him, but written testimony from people that met him. Anyway.
There are no photographs of Joseph Smith. There are drawings or paintings of him, but no photographs.
That's just, trust me, bro.
Yeah.
That's all you got.
What, by the way, why is it that flat earthers say bro all the time? I don't understand.
I don't know. Austin sure likes it. And I
Well,
took,
he's not the only one. I mean, Nathan Thompson likes it, and they're always broing each other all the time.
yeah, and like, are you broing me, bro?
Cool story, bro.
So let's see. Oh, let's see. Vadim says, please ask Dr. Faulkner to say to, I don't know, is it Bodhi Hodge, that he has fans here. Who's Bodhi Hodge?
I just saw Bodhi this evening. He was came into the office, and his office is 1, 2, 3, 4 doors down the hall from me, and he was here with a couple of his family, and so he was. I just saw him just about a half hour before he went online today.
So who is he?
He's a speaker for Answers in Genesis. He's I guess he's, I forget what department he's in, but he does speaking and writing for AIG quite a bit.
Okay.
He's been an employee for AIG for 25 years, I guess.
Awesome. Okay.
He's an engineer by background, but
Texas Troy, the intelligent flat earther, says he doesn't use bro. And, then
he's just not a flat earther. He has his bona fides don't add up at all.
It's like he's just doing it for the comedy, and he is a funny guy. He's on the Discord server, and it is comedy. I do enjoy him on there. And Texas Troy is asking, he's already in the inner sanctum, asking if Lake Titicaca is level or flat.
Well, I've been there.
Oh, you have?
I have. I need to send you a picture. I've been trying to look. I got it somewhere. I was there about 5-6 years ago. I was in Bolivia, and I had lunch at a restaurant by the lake. Got a couple of photos. So if I can find them, I'll send it to you.
Awesome.
So you know somebody who's been there. I can attest that it really does exist.
Awesome.
And it looked flat to me.
All right. Well, we are over 2 hours now, and we.
Oh, really? It's been a blast. I've really enjoyed it. Time's gone by so fast.
It has been good. If you find if you're on Facebook, people, you might find yourself in the group that I can't remember the name of. Maybe I'll get it. I'll put the link to it in the description. Any flat Earth group I get an invite to. As soon as somebody found one, I'm in it. And if they're an echo chamber, I've already been kicked out.
Yep.
So
I've saved a lot of time. I just don't even go there.
Yeah. So anyway,
I did go on to FE 24/7 once. And I lasted.
Oh, the Discord server.
Yeah. I went on there I lasted about a half an hour, and finally, I won't tell you the name of the person, but you would know the name probably. And he declared I wasn't being honest, and he kicked me out.
Yeah,
and the reason why he declared I wasn't being honest was they have these 3 questions they ask you, and it's designed to get you down the primrose path to then forced to agree with them that you don't know what you're talking about if you believe the Earth is a globe. Well, my problem is I do know what I'm talking about. We didn't even get really into the first question because I was trying to answer the question honestly, and they didn't want to hear it. And so basically, I was declared to be dishonest, and they booted me out. I don't know if I've been banned, but why would I go back after the treatment I got? I'm not interested in going back again.
Yeah.
By the way, they talked about me for about an hour after that, and then the next day they talked about me again for another hour. And they'll probably talk about me in the next few days too, because some of them will probably watch this program. So
I invited a few people. Specifically, I mentioned on Twitter and Indio, who's one of like basically it seems like he's the owner of that server.
well,
Indio
he's on there
007.
quite a bit. I've heard him speak many times.
Yeah. And
But he talks about a lot of other things besides flat Earth. He talks about all sorts of things.
I kind of get the impression that is his entire life, is that server. So anyway,
It could be.
And he's occasionally on Twitter, and he's of the impression that it's impossible to measure an angle to a curved surface.
Yeah, that's the whole navigation thing, which is something I could have talked about, but you've been dealing with that quite a bit lately, and so has Craig at FTFE. He's been talking about it, and he's actually done navigation. There you go. Who's author of that book?
David Birch.
Okay, all right.
So this book, and then David Birch also wrote a book of his voyage from the West Coast to Hawaii. So when I had Hip Hop Hippie on with Craig, the specific 2-star fix that I gave them to use was not this book, but another book by him.
Yeah. I listened to that program, and I remember what you gave them. It had a pretty basic problem there. I could have probably solved the thing myself, but it would have taken me a little longer. I would have done it a bit differently. I would do it the way an astronomer would do it, which is different the way a navigator does it.
Yeah.
But navigation, sometimes people say a sextant only works on a globe Earth. That's not quite true. A sextant doesn't matter what the shape of the Earth
Measures
is.
angles.
All it does is measure angles, but what matters is what are you going to do with that? And the whole theory and practice of celestial navigation is based upon the globe Earth. They talk about the charts, the tables that give you the GPs, and they have no idea how those tables are generated. Well, as an astronomer, I know how those tables are generated. Oh, yeah. It's generated with the assumption of the Earth being a globe, not flat. There is no theory of flat Earth navigation. It's sort of like when people are saying that the Saros cycle has been used to predict eclipses. Well, give me evidence that it ever has been done. Well, the claim is that you can navigate using a sextant on a flat Earth. I said, well, give me the practice, give me the technique that's used, and they'll never give you that because there isn't such a thing. Now, they've been talking about celestial navigation quite a bit in the last few months on flat Earth circles, quite a bit, and that's become very fashionable to say, well, you can't even get a fix because on the Earth's surface it's curved. And the late Rob Skiba, one of the FEICs, gave a talk where he said things flat mistakes that globe earthers make. One thing they want to do is they want to import things from globe Earth into flat Earth, and that's a good point. But it also goes the other direction. Flat earthers should never be importing flat Earth ideas into the globe Earth. So you'll get this diagram showing measuring an altitude like this. And they think it's measured over top of the GP, is giving you this triangle.
Yeah.
And that's not what those diagrams are showing at all. It's showing the tangent. There you go. It's showing a tangent plane at your location with a tangent plane to the Earth's surface as your horizon. And you're measuring altitude with respect to that, or you're converting it to that point. You have to correct for dip and atmospheric refraction, all that things. But the tables are basically based upon the altitude above the astronomical horizon, not the apparent horizon, not the geometric horizon, but the astronomical horizon. And those are terms that flat earthers don't seem to understand. So the criticism about you can't measure an angle on a curved Earth is they've just imported an idea from flat Earth into globe Earth, and you can't do that. That's just not allowed.
And $10,000 if they can do it.
Yeah, and they're never going to. And of course, yours is a real challenge because you have to put an escrow. I have never seen a flat earther do that. It's never happened. They're the arbiter of when this meets the criterion. So it's a waste of time to try to collect. You're never going to collect.
Yeah, and not only that they often they don't even have the money.
Yeah,
right. That's number one. Number two, they they're the holder of the money and the arbiter, and yeah, they'll
Yep.
never agree. The Jim Tanker says, my apologies if I was a bit of a butt tonight. In my defense, I was drinking 160 proof moonshine. I'm sticking with the Eric DeBay's 200 proof Toonshine.
I'm sticking with Cheerwine.
And I see that you've joined the Quibbler. Thank you very much, the Jim Tanker. Hey, I need my positions challenged, and I'm sure Danny will agree. If we can't take the heat, then our positions should not be things that we hold, right?
Yep.
So, effed up world smells pseudoscience. He says science doesn't reject observations we make, like stationary Earth and rotating sky. Oh, effed up world. Science would say there are multiple explanations for that one observation, and then you need to bring in the other observations and bring them into an agreement with each other. So, all right, well, that's what we will do tonight. I have a debate on Tuesday lined up with Chris Wood, who is, as we call, a religiflurf. Super aggressive. Like, I think he's probably just going to want to talk about the Bible the whole time. So, Danny, any I know you don't really have, you do have a YouTube channel, but you don't do stuff on it.
Not much.
I do have the link to your blog in the description, and I will try to get the link to the Facebook group in there. Anything else
Okay.
you'd like to say as we close
No, I
up?
think we pretty well covered it. I want to thank you for this opportunity to come on. It's been a lot of fun. I've enjoyed it. It's our first time together. Hopefully it won't be our last. We can maybe do a program in the future. Talk about the physics if we want. Talk about the biblical argument sometime if you want for flat Earth, and try to keep that argument.
I think that would potentially be a topic for this particular channel, because I don't myself address it. I'm just like it's just a claim, but I think the Jim Takers take another shot at you there.
What did he say?
He says Faulkner is still an anti-intellectual shill, getting paid by big. I don't know who big what insert whoever's. Anyway, Judy's wondering, more Lego globe. I will be, yes, the globe back here. I maybe on Tuesday if I don't have somebody else after. I'll do that. So don't close out the Zoom call when we're done here. But
Okay.
Thank you everybody for joining, and we'll see you again next, maybe Friday. I'm interviewing Kelly Weil, who wrote a book similar to this, just came out on 2/2/22.
I read that book.
I sent
I've got
him the copy.
Where is it? I have it somewhere in here, but I just read the book last week. It's a good book. It's a good read. It really is. Have you finished reading it yet?
I have not. I'm chapter
Okay.
1.
All right. Well, it's a good read. I think you'll enjoy it. And it was very helpful to me.
Awesome. And yeah, I'm looking forward to that. So that might be the next Toon show, or maybe I'll do it on my other channel, probably the other channel. Anyway, thanks a lot, everybody, and we'll see you next time. There it is. They can still hear us talking, even though the song is going. So you can give them one final goodbye.
Okay. Well, thank you for coming tonight. I appreciate it. And I hope to do this again soon. Come back and see us sometime.